Here we have example 3.1 where we have one triangle embedded in the other. A lot of times you're going to see these symbols. These symbols mean parallel lines. We haven't talked a whole bunch about parallel lines, but it is a necessary feature to make these triangles similar. As soon as you figure that one triangle is embedded in the other and you have these parallel lines, you know you have similar triangles. So we want to start off doing the same thing we did before. Draw one big triangle, one little triangle, and set up everything you know. So here's my big triangle. I know that the big triangle, which is MNZ, has a vertical length of 15, and then the big length in the drawing says 6h plus 5. I draw a smaller triangle. This is the one that's embedded, and that would be HPZ. I know it has a vertical height of 9. Now here's an example where I can't add. I need to find the distance from P to Z. It wouldn't make sense to add the two expressions, but rather I need to subtract them. And so I'm going to take 6h plus 5, and I need to subtract out, if you subtract, make sure you put parentheses, 2h minus 3. As I put the parentheses there, I recognize that I have to distribute that a negative across both terms. And so this is 6h minus 2h, that's the first distribution, 5 plus 3, because minus a negative would be a positive. That tells me that the length from P to Z is going to be 4h, because 6h minus 2h is 4h, and 5 plus 3 is plus 8. 4h plus 8. Now, once I have that set up, I can move forward, do a proportion, and tell you what h is. Then I can come back and tell you the length of each of those segments. And so we can do something like this. We can say 15 is to 9. Those are always nice when you have something that you can reduce later on. Big triangle to little triangle, as 6h plus 5 is to 4h plus 8. As I said a second ago, I can reduce this. I see that both of those are divisible by 3. And so if I divide by 3, I can make a simpler proportion and say 5 is to 3, as 6h plus 5 is to 4h plus 8. Don't ever try to cancel anything with your expressions. It'll get you into trouble. Now as I solve this, I'll multiply by my common denominator. Common denominator is 3 and 4h plus 8. Distribute to the first fraction. The 3's could cancel out. This would give me 5 times 4h plus 8. To the second fraction, the 4h plus 8 is going to cancel out, and so I'd be left with the 3 times 6h plus 5. Try and distribute in here. 5 times 4 would be 20h. 5 times 8 is going to be 40. 3 times 6 is going to be 18h. 3 times 5 is 15. As I move those terms, this 18h would come over, so 20h take away 18h is going to be 2h. And then I would take this 40 over. As I take the 40 over, that's going to be 15. I'm pausing because it kind of scares me there. Sometimes when you work these problems out, you're going to get crazy answers. I will not have any crazy answers on the test in the sense that this doesn't really make any sense. What I'm saying is when I take that 40 over, 15 take away 40 is negative 25. That means that h is going to be a negative value. When I divide by 2, I divide by 2, h is negative 12 and a half. That's going to be problematic. When I plug this back in here, that's going to give me a distance that is negative. Because I just throw these numbers together for your homework problems and for these examples, it's not perfect. In other words, I made a mistake. So when I plug this in here, I can still plug it in, we can still get an answer, but it's not a feasible answer. It doesn't make sense. 6h plus 5, I would say 6 times 12 and 1/2 which is 75. Negative 75 plus 5 is going to be negative 70. And that doesn't make any sense whatsoever. We'll do the same thing with this one. When I plug that into my calculator, 4h plus 8, that would be, what, negative 50? Negative 50 plus 8 would be negative 42. In your homework, I would be concerned with that. If it happens, make sure that you ask about it. It will not happen on a test. I make sure that I check those answers before I do your test, so I guarantee your answers would have to be positive. If you get a negative, you know you did something wrong. There had to be a problem somewhere.